been reading comments and a lot of you been asking to put water in a vacuum. So let's check it out. So I got water over here. We're gonna fill it up, the beaker, with water. Boom. Then we're gonna cover it with the vacuum chamber and then turn it on and see what happens. You can see a little bit of bubbles start going, and whoa, it start boiling. How cool is that? Looks like it's boiling a lot. Wow. Pretty awesome, huh?
At the beginning of the video he shows a CD or a disc. He immediately draws the geometric shape of an oblate spheroid. We can see how he separates the oblate spheroid with a disc that has a hole in the center. Then, below he draws a circle with a swastika inside and immediately paints it completely black. From this black circle rays come out and 3 rays pass through the hole in the center. Below he writes, "Still." One of the possible meanings of this black circle may be the black sun. He draws reliefs on the edge of the hole and writes North Pole. And above this hole inside what would be the celestial vault he draws a star, the polar star or Polaris. He marks 2 points and connects them in a circle and writes, equator. He draws 2 lines that go down from the polar star to the 2 points. The lines form a triangle. He highlights 2 of the rays coming out of the black sun and also forms a triangle but vice versa. And he writes, "As above so below." It's one of the 7 principles of Hermes Trismegistus. It appears on the Emerald Tablet and then in the Kabbalion. He erases the intersections and draws the sun and moon. And he makes a gesture of rotation. He draws 2 arrows to show the distance of the Moon and the Sun. Both are 3,300 miles or 5,310 kilometers away. Then he measures the diameter of the Sun and Moon, being the same with a diameter of 32 miles or 51 kilometers. He draws continents on the surface and on the other side as well. He points both sides and writes, "Same." Below he writes "Summer Land." He draws rays coming out of the black sun and writes, "Northern Lights." The center of the drawing is equal to the Mason symbol, which is a square and a compass. He points out the ray coming out of the black sun toward the Moon and then he erases the face of the Moon. He makes signs explaining that the sun doesn't light up the Moon. Who does it is the black sun.
Good evening, everyone. This is actually a follow-up video to a video I did about a year ago showing how, as you can see here in these pictures, how the reflection of the sun on the ocean water and how it tends to always come right up to your point of view due to perspective, as you can see in these photos here. And I also went on to show you how the moon does the same thing, and that can only happen on a flat surface of water, was the point of the video that I was making for you. So also I went on in the video to show you how I could take a bowl of water and then take a glass ball of water and duplicate a sphere of water, which is what I did here. If you guys can remember, I poured water into this bulb and then I sealed it, put a little food color in there, made it blue, and pretty much duplicated a sphere of water. And then I went on to, like I said before, fill up the bowl of water. And then I continued to demonstrate for you guys that you could only get a reflection off of the bowl of water with a flat surface on top. And we could not get the same reflection from the ball of water. So anyways, at the time, I thought it was a really, really simple way of proving my point of the sun reflecting off of the flat surface, that it could only happen on a flat surface, not a sphere of water. So I had a lot of people say, well, hey, that's not accurate, that's not right, because there's glass on the outside of the water, so therefore you wouldn't get the same effect as you would with the bowl of flat water, where the light is actually reflecting off of the water itself instead of off of a round surface of glass. So I put it in the back of my mind, and I have been pondering on it for about a year. And you know what, guys, I'll give you that one, because that does make sense. Water's water, right? So, okay, today I'm going down the highway, and remember this reflection I showed you right here, guys, on the ocean? Okay, I'm driving down the highway, and I look over to my right at the frozen lake, and here's what I see. Lo and behold, the sun reflects off of frozen water just as it does the water when it's not frozen. So anyways, I thought to myself, wait a minute, I can't duplicate a sphere of liquid water, but I can duplicate a sphere of frozen water. So on my way back home, I stopped and bought a package of balloons, went home, filled a balloon up with water and food color, put it in the freezer, and out popped a sphere of frozen water. So now let's do the test the correct way. If you can remember, in that first video I showed you guys the reflection that you're looking at right here, which is light reflecting off of a flat surface. This is the only way that you can get this type of reflection, is on a flat surface. Okay, now check this photo out here. Now this photo is shot at 121,000 feet. What do you see? You see the same reflection as you've seen here and as you've seen here. Once again, these reflections can only take place on a flat surface. Now, let me show you. Okay, same as before, except this time we're using frozen water. As you can see, at sunset, check it out. The reflection moves right atop the cross of the flat surface of the water, and it follows you, follows your perspective, your line of sight, wherever you go. There you see. That can only happen on a flat surface of water. And we're going to prove that right here. Here we have a frozen sphere of water that I've put food color in, of course, and it's eventually going to make a mess here when it starts to melt. But that's the cool thing about this, is when it starts to melt, it's going to be liquidy on the outside. So we're going to get that perfect chance to see if we can get the same reflection off of a sphere of water. Okay, now even the light above, see the light above reflecting on it? See, it's a round surface. It can't reflect that. It can't reflect the same way. It has to be a flat surface. See the light on the ceiling reflected on it? It's just a dot. That's all you're going to get on a sphere, is a dot. You're not going to get that long stream of light, because that has to be a flat surface in order to get that reflection. Anyways, let me go on ahead and prove it to you with the light source here, even though I just proved it with the light on the ceiling. Okay, put it back here like it's sunset. Nope, still a dot. You can see here, still a dot. Put it back here, over here. Still just a dot, no reflection. You can't get that long light of reflection on a sphere of water. It's just not going to happen. As you can see right here, let's do a sunset. Look, sunset, look. It just doesn't happen. As you see here, when we compare, looks nothing alike. It's impossible on a sphere. Impossible. And once again, here, looks nothing alike. Like I said, it is impossible. It cannot happen on a sphere of water, because a sphere of water does not exist. But you know what does exist? A flat earth. And that is the only way that you can get a reflection from the sun like this right here that you're looking at, is from a flat surface of water on a flat earth, as you can see right here. So regardless of what you globers say, this was a legit experiment with water, spherical water, and a flat surface of water. And I proved to you the only way to get this reflection right here is on a flat surface of water. And that can only be found on a flat earth. Everyone, thanks for watching. Have a good night and God bless.